Right? So you can even build desktop-based applications using Node. So in general, it is just a runtime. It is basically just a runtime using which you can execute JavaScript. Right? I'm assuming that you might have installed Node in your machines, and later we will see how you can run a small program in Node. But what is a specialty? Right? And especially, what is the rage about a JavaScript runtime? Now, if you look at it, right, JavaScript is a pretty inferior language. When you compare JavaScript with other languages, right, languages that are feature-full, using which you can build much complex applications. When compared to those languages, you take for example C#, you take for example Java, you take for example C++. So when you compare to those languages, JavaScript is pretty inferior in its capabilities, and it is designed to be like that, right? Why? Because the origins of the JavaScript are very humble. People wanted a very simple language that can run in the browser, and in those days, the infrastructure availability for the browser itself was very limited, and you wanted to run a program inside the browser. So obviously, the author realized that if they create a more powerful language, then obviously it will take more powerful runtime, which will increase the overheads on the browser. So what he decided was a very basic language with very limited constructs, very limited support for data types, and using that you can achieve what you wanted to do on the browser, right? And those days, 15 years ago, all you wanted to do with JavaScript was just do some basic data validations, right? So the language was pretty much okay with doing that. Now, how can I use that language that was built for writing data validations on the client side, right? So when I say it is very inferior, what am I talking about? Let us look at this. What are all the data types supported in JavaScript? Very simple. There are only 6 data types supported in JavaScript. So for example, you say number and string, true, boolean, type of a function, and type of an object, and type of undefined. That's all. Right? These are all the only types. Everything else will fall under one of these types. So if you take a type of array, it will be an object. Right? Anything else, if you take anything else, type of window will be an object, but type of window with a capital W will be a function. So everything else will fall under one of these types. Number, string, boolean, function, object, and undefined. And within this, right, only these 3 can be used to represent raw data. Number, string, and boolean. Only these 3 are used to represent raw data. Nothing else. So the overall data types that are supported by JavaScript is only 3: number, string, and boolean. But if you have worked in Java or .NET, right, you will realize that in those languages, just to represent a numeric value, you will have at least 10 to 12 data types. Right, only for numbers. And the strings, you will have a different variation, and they will also have their own exotic collection of data types supported in the applications, but in the language, in the runtime. But JavaScript is very simple language. All you have is only 3 data types. Only 3 data types. That's it. Nothing else. Right? Now, this is how limiting the language is. Number 1. Number 2. When you use a language for building complex applications, you typically want a construct for creating classes, right? Do JavaScript have a dedicated construct for creating classes, at least for now? No. You use functions for creating classes, or you use functions in a different way so that the functions behave like classes, constructor functions. This is as of ECMS 55, but in the next version of JavaScript, ECMS 56, you have constructs, dedicated constructs for classes. But at least as of now, you don't have dedicated constructs for creating classes. So now when it comes to data types, when it comes to programming constructs, when it comes to every aspect, right, the language is very inferior. The language is very limiting. And how you use this language to build complex large-scale applications? What is the need for it? Why would anyone do that, right? So the advantage of Node is not JavaScript. In fact, right, the advantage of Node is not JavaScript. Then what is it? The way by which it executes internally, right? The scheduling pattern that it uses internally, right? That is a core advantage of JavaScript. Now, what is the scheduling pattern that it uses? Okay, so in fact, even before getting into the scheduling pattern, what do you think is the advantage of Node? Let me ask you this question. What do you think is the advantage of Node? Why should one portable? Okay, very good. So I can put it in very good, portable, lightweight. Okay. Anything else? Good, right? Most importantly, probably you are right. Most importantly, the lightweight nature, especially speed, exactly, right? The lightweight nature is what is the biggest plus point of Node, the lightweight nature. So when I say lightweight, what do I mean by that? The resource requirements for hosting your application, right? The resource requirements for hosting your application is very, very less when it comes to Node, right? One of the very popular use cases, not use cases, one of the popular implementations, right? Till then, hardly anyone had the courage to use Node seriously for enterprises, for large-scale applications. But this incident happened. One of the biggest companies in the world, they migrated web services, their web services for mobile applications. They migrated their web services that were built in Ruby on Rails to Node.js, right? And in the Ruby on Rails version, in the ROR version, they had to have 30 servers in a cluster, in a load balancing cluster, to handle the load, right? Now, when they when they re-engineered their application in Node.js, they rewrote the complete application in Node.js. And when they rewrote the complete application in Node.js, right, they were able to bring down the number of servers from 30 to 3. So this is almost 90% resource reduction, right? It is almost 90% resource reduction. Plus, on top of that, at times they also witnessed that the the performance is 20 times more. Right? The performance is 20 times more. Now they were able to bring down the number of servers from 30 to 3, and at times they also witnessed that the performance was 20 times more. Right? Which one? Any idea? Do you know which one is I'm talking about? Okay, it is LinkedIn. I'm sorry, not LinkedIn. It was yeah, LinkedIn. I'm sorry. Yeah, right. It was LinkedIn. Highscalability.com. So go to highscalability.com. So I'll share you this blog link with you. Right. So this was a very old blog, written in 2012, and actually they updated it much later as well. Right. So they were able to cut down the number of servers from 30 to 3, 27 servers cut, and up to 20 times faster. Right. So this is one of the biggest advantages of adopting Node.js. Okay. This is one of the biggest advantages of adopting Node.js. So when something gives you an advantage, there has to be some disadvantages, right? There has to be some disadvantages. What are they? You know what are the disadvantages? The disadvantages are your application tend to become more complex, right? The way you write your application itself is going to become more complex. The structure of your application is going to be more complex, okay? But right, little difficult to manage until you know, right, what you are doing. It will be a little difficult to manage. It is not as straightforward as a Java application or a .NET application. The complexity of building the application is increased. The way you manage them is multifold. But the biggest advantage that you get is the resource reduction, right? It is very, very lightweight and it is very fast. Okay. Now, you know what is the biggest thing? How does it offer this performance? The biggest irony is it offers this the lightweight nature, right? It requires less CPU, it requires less memory because it is single threaded, right? It is single threaded. Now, at least the core runtime is single threaded. Now, with a single thread, how is it possible for me to build a server application? With a single thread, how is it possible for me to build a server application where in which I can process requests coming from hundreds and hundreds of users at the same time? And how can a single thread process all these requests and still give me this speed, right, that we are talking about? Now, the idea is using a simple scheduling pattern called event loop, right? Event loop or async event loop, single threaded event loop, async event loop. So what is the idea behind this async event loop? I'll explain you what this is, right? Let's assume, right? So I'm going to take a simple case study and we will discuss about different scheduling patterns that are used in different languages and runtimes. Okay. Now, as a freelance consultant, right? So I visit a lot of companies for training programs, for consulting, for a lot of reasons. Now, one of the things that I have noticed when I visit these companies is that almost all of these organizations follow a very standard process of engaging a visitor, right? The reception where visitors report to and the process that you follow, right, to accommodate the visitor inside the office premises is not straightforward in the sense like, I cannot just like that go in and to an office premises. Now, what is the process that these guys typically follow? Now, these are all the processes that they follow, right? So let me quickly make a list. Number one, right? Once I reveal who I am and why am I there in that particular office, who has invited me, etc., 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 the receptionist would hand over a ledger, right? We are still maintaining it manual in a lot of places. So she would give me a ledger where I am supposed to make an entry about myself. So I will have to fill in the visitor ledger, number one. Number two, most of these organizations are in custom bounded environments. So, not anything cannot be moved out freely from these offices. So typically they make a entry of every electronic equipment that comes in and that leaves the premises. So what I am supposed to do is I am supposed to also make an entry in the laptop ledger, right? And then I will also wait for my contact person, right? So whoever has invited me, right? Whoever has invited me, he has to come and accompany me. I cannot be just freely roaming around in the office. So he should come and accompany me. Wait for the contact person to accompany me, right? So these are all some of the steps that most of these organizations follow. So when I report to that particular office, I need to fill in a visitor ledger, I need to fill in a laptop ledger, and then I need to wait for my contact person to accompany me. Once he comes, he can accompany me to the respective venue. Now, I am one type of visitor that these receptions handle. The other type of visitors that these receptions handle are their own employees, right? So why would they have to report to the reception? Maybe they would have forgotten their badges, right? So only when you swipe the badge, you will be gaining access to it. So maybe they would have forgotten to bring the badge. So what they will have to do is they will have to authenticate themselves in the sense like, they have to prove in one way or the other that they are the employees of the organization, and then right? And then they will have to fill a temp badge ledger. They will have to fill a temp badge ledger, and then they can collect the ledger and move away, right? So these are all the two types of visitors that the reception handles. Let's assume that, okay? So first one is a non-employee like me who has to spend a day in their premises. The second one is their employees who forgot their badges. Now, how does the receptionist handles both of us, right? How does the receptionist handles both of us? So let's assume that this is your reception, right? So, right? So this is your reception, and you have the receptionist sitting here. Okay, so this is a huge table, and you have the receptionist sitting here. Now what I do, I go, let's assume that this is the receptionist. So here is the receptionist. Now I make my presence here. So I say, first I report to her and I tell her, hi, I'm Magesh and I'm here for a training program. Now what she does, she hands over the ledger to me, asking me to fill. Now I start filling the ledger. So I take my own sweet time, collecting my pen from the bag, and I start filling the ledger. Meanwhile, there are quite a few others waiting behind me. Right? And they also want to undergo this process, so that either they are employees who lost their badges, who forgot their badges, or they are visitors like me, right? So I am first in the queue. So she gives me the visitor ledger, and I take my own sweet time in filling the ledger, right? Say I take a couple of minutes in filling the ledger. Now, while I am doing this, this guy, right? So this guy grows impatient. So what he does is he tries to get the attention of the receptionist. He says, hi, I am here, I am also waiting. So what the receptionist says is, wait. I cannot handle another visitor till the first visitor is being attended to completely, right? Till the first visitor is attended to completely. So what does it involve to attend to the first visitor? I have to fill the visitor ledger, which I take a couple of minutes, and then I have to fill the laptop ledger, which I take another couple of minutes, and then I wait for the contact person to come and accompany me. He takes 5 minutes to come to the reception, right? So for those 10 minutes, she says she will not be able to attend to another visitor till I am completely attended to and I leave that particular place, right? You understand what I'm saying? This model is, you have only one receptionist. So this is single threaded. She can handle only one visitor at any point of time. I'm sorry, there is only one person who handles all the visitors, right? Single threaded, only one person. And while I am filling the form, right, while I am filling all these ledgers, she cannot attend to anyone else, right? So I am blocking completely. So she functions in a blocking fashion, right? So until I finish the job, she will not be able to do anything, right? So she has to wait for me to complete, right? So this is single threaded blocking, synchronous blocking, right? There are several ways by which you can call this, but this is called as single threaded blocking. But is this advisable? Is this model advisable? Is it model scalable? Right? Definitely not. Sometimes you will find the reception full of people who want to, get the attention of the receptionist, and because she has the capability to handle only one visitor at any point of time, right? Always there will be a backlog. There will be a huge queue waiting for the attention of the receptionist. So definitely this is not scalable. Okay, now what is the solution? Right? Now the management realized that the reception is becoming a big mess. So they try to find out a solution. The solution is this: they hire a lot of receptionists. So the idea that goes is like this: Sorry, 1 second. Right? The way it goes is like this. I report first. So I ask the receptionist, I'm a visitor here, so give me the visiting ledger. So what she says is, okay, I will not be attending to you. I will have someone else attend to you. Right? I will have someone else attend to you. So she calls someone. There is a, assume that there is a bell on the table. So she rings the bell. Someone comes from the back. Right? Someone comes from the back and they take care of attending me. So I have been allocated a receptionist and I will be processed by this receptionist. Is that clear? Now similarly, the next guy moves in. And he says, hey, I am an employee and I forgot my badge. Now she rings another bell and one more receptionist comes in and this guy is handed over to the other receptionist and says, okay, now you handle him. Are you with me? So for every visitor, you have new receptionists to handle them, right? You have new receptionists to take care of the process. Now, if you look at this, right, you get new receptionists as and when you need, and this is multi-threaded, right? This is multi-threaded. But if you look at the way they function, can they handle more than one visitor at any point of time? No. One receptionist will always handle only one visitor at any point of time, right? So it is still blocking, right? It is still blocking. Okay, very good. But is it scalable? Definitely not scalable, right? How many people I will employ in the reception? Right? Obviously, I cannot employ more than 2 people. So this is definitely not scalable. It may be a viable solution, but it costs a lot. It costs really a lot of money to just to run the reception, right? Now, what is the solution? What is the solution, right? Now, let us look at this model. So let me get rid of everything completely. Right? So the management figured out, okay, so this is not the right way of doing it. So they hired a consultant. The consultant started sitting in the reception to understand what the hell is happening. And he realized one thing. What is it? When the receptionists were handling the visitors, right? When the receptionists were handling the visitors. So if you take a visitor, when the receptionist was handling the visitor is engaged in filling the visitor ledger for 2 minutes. What does the receptionist do at that point of time? She is waiting for the visitor to complete that. And then the visitor takes 5 minutes to fill the laptop ledger. What does the receptionist do till that time? She waits for the visitor to complete. And then the visitor waits for the contact person to come. So what does the receptionist do till then? She also waits. Now if you take a complete timeline, right? If you take a complete timeline, if I draw the timeline like this. So this is the receptionist, right? So this is the receptionist and this is the visitor. This is the visitor. Now, okay, the visitor I will, yeah, that's better. Okay. Now let me use a slightly different color so that we can differentiate. Now what the receptionist says, hey, fill this ledger. Now I take my own sweet time filling the ledger and then I hand it over. And then immediately she gives me the laptop ledger and I take my own sweet time filling the laptop ledger and then I hand it over. And then, right? Now both of us wait for the contact person to come. Both of us wait for the contact person to come. Now if you look at this, right? If you look at this, what is happening here, you will realize that the receptionist was, right? The receptionist was, oops, what happened? Right? From here to here, she did nothing. Similarly, from here to here, she did nothing. And similarly, from here to here, she did nothing. So the only time she was engaged was giving me the ledger, receiving the ledger back, giving me another ledger. That's pretty much what she did. I was pretty much engaged in doing all the work, right? I was filling the ledger, and both of us were waiting. So at this point of time, neither of us did any work, right? But at least I was busy, and while I was busy, the receptionist was completely free, but waiting for me to complete. Why? Because of the blocking nature. She cannot handle another visitor until I am done, right? So she had to wait. She had to wait. So when the consultant sat in the reception and analyzed what's happening, she realized that there are 5 receptionists handling 5 different visitors at the same time, but most of the time they are idle. They are only doing the coordination, but most of the time they are idle. The job, the visitors were busy filling the ledgers, but they were completely idle. Now, they realized that the problem is with the blocking nature. Right? The problem is with the blocking nature. If you are not made to wait, right? Don't wait. Once you hand over the ledger to the visitor, move on to the next one. Don't wait there, right? Don't wait there. So what they did, they devised a plan. The plan was this. The plan was this. I'll explain, right? Now, they realized that you don't need too many receptionists at any point of time. Just one receptionist is more than sufficient. Right? Just one receptionist is more than sufficient. How do you do that? Okay, so here is the receptionist. So she is here. I'm sorry. Right? So you have a receptionist, and they kept a large tray. Right? They kept a very, very large tray in front of her. A very large tray. And I'll explain you what is the role of this particular tray. A very large tray. They kept a tray. And the idea of the tray is the tray will decide what the receptionist has to do at any point of time, right? What the receptionist has to do at any point of time. And by the tray, she is given with a few plastic tokens, right? Number tokens, what you have in the hospitals, all right? So each visitor is given with a token, right? A number. And what the visitor has to do. So one visitor walks in. So one visitor walks in. So when a visitor walks in, she says, okay, here is your visitor ledger. You go about writing this, filling the ledger. I will not wait for you. Once you are done, right? Once you are done, drop the token in the queue. Right? Once you are done, drop the number in the queue. Then I will understand that you have done and I will attend to you. Right? So now this guy is moved away from here. I'm sorry. Right? So this guy is moved away from here, and his job is go about filling the visitor ledger. While he is doing it, right? Another visitor comes in. Another visitor comes in. And she once again does the same thing. She says, okay, so who are you? An employee? Now fill the temp badge ledger. Fill the temp badge ledger. I'm sorry. Fill the temp badge ledger, and once you are done, drop the token in the queue, right? Drop the token in the queue. So this guy goes out of this, and then another visitor comes in. Now 10 visitors were there, all 10 were given a token, and they were given the respective ledgers. So they had to fill the respective ledgers, and once they are done, they will drop the token here. Now once all 10 visitors are attended, the receptionist's job is to keep scanning the tray, right? So when she finds a token, she attends to him and say, okay, now are you done? Now here is your laptop ledger, fill it, and once you are done, drop the token here. Now she once again keeps scanning the tray, and whenever she finds a token is placed, she takes it, attends to that particular visitor, and then relieves him to continue his work, right? But she doesn't wait for anyone to complete, right? She doesn't wait for anyone to complete. This is what you call as single-threaded non-blocking, right? You don't wait for an operation to complete, right? Especially if the operation is done by someone else and I have to simply wait for them to complete, right? I don't do that. What I will do is I'll tell them, boss, you do your work, and once you are done, let me know, and then I'll proceed with the remaining pending tasks, right? The remaining pending tasks. So this is what you call as a single-threaded, non-blocking or async execution. And this tray, right? What we visualized as the tray here is what you call as the event loop, right? What you call as the event loop. Does it make sense? Okay. Now, who are these guys, right? With respect to Node, who are these guys? Who are these guys? These are all the guys who do core IO operations. These are all the guys who do core IO operations. File read write, right? And then network read write, network read write, memory streams, right? Memory streams. Now, when you initiate a read operation, right? When you initiate a read operation, it takes some time for the hardware to get moved and to read the data. Yes or no? Right? What Node attempts to do is, instead of waiting for the read operation to complete and to get the data, it moves on to the next one. Is that clear? So, this model of execution works perfectly fine as long as the receptionist's only job is coordination. Right? As long as the receptionist's only job is coordination. She should not be engaged in any task that runs for a long period of time. As long as she is not engaged in a task for a long period of time, right? As long as her engagement with these guys span only a short span of time, she can very easily attend to any number of visitors at the same time simply by not waiting for them to complete the task. Right? So, Node functions in this fashion. And these are what you call as your IO activities. Right? These are what you call as your IO activities. When you look at other runtimes, like say for example, a Java runtime or a .NET runtime, typically how are the servers built? Let us take a basic web server. Right? Let us take a basic web server. How are the servers built? You ask for a resource. So when a request for a resource comes in, right, the file read and write has to happen. While the file is being read, what is the runtime doing? The runtime is not doing anything. And for that, it creates a separate thread. Every request results in a separate thread. And what those threads do while the file is being read? They don't do anything. They just wait for the file to be read. Right? What Node tries to do is no. Right? If the file read operation is going to happen, why do I have to wait? I will move on to the next task, and once the file read operation is completed, I will start coordinating from there, right? So that is a model that Node takes, and this is what you call as a single-threaded async execution model or a scheduler. And that scheduler, right? Internally it uses a loop wherein the events are registered, right? So once a file IO operation is done, an entry is made into the loop saying that, hey, I am done. Now take it forward from here. Right? Now, these operations, right? When I said, filling the ledger. So if I translate that to raw file IO operations, right? We are talking about durations in terms of 4 milliseconds. We are talking about durations in terms of 4 milliseconds. So even if a file read operation takes just 4 milliseconds, Node doesn't wait for it, right? It just simply moves on with the next task. And once the file IO operation is done, the operation is supposed to make an entry in the event loop, which will be later processed by the Node runtime or the single-threaded runtime. Is that clear? Do you understand? So this execution model works perfectly if the runtime's job is only coordination. Right? If the runtime's job is only coordination. If you make the runtime do anything a lot more complex, then what will happen? Say for example, one visitor comes in and he keeps the receptionist engaged for a long period of time. And when that happens, what will happen? Right? When that happens, he is completely keeping her engaged for a long period of time. When that happens, more and more and more and more visitors will be waiting for her attention. Right? You will have more number of items to be processed in the queue, which may become an overhead. So no one should disturb the execution model of the receptionist. They should not engage the receptionist for a long period of time. Their interaction with the receptionist has to be very, very short span of time so that she can attend to all the visitors and coordinate them. Does it make sense? Pablo, are you okay? Any questions? Frederick, are you there? Are you okay? Do you understand what we are discussing? Do you guys understand what we are discussing? Okay, so here is the question for you guys. What if the receptionist has to do something for a long period of time? How will I handle it? Right? What if the receptionist has to do something for a long period of time? Say for example, New Year approaches. Now, once New Year approaches, the organization has decided to give gifts to all the employees. Now, what they delegated that responsibility to the receptionist. They delegated the responsibility to the receptionist. So, they created, they brought in a large box containing all the gifts for each and every employee. And the gifts are all marked by name. Okay, so you have 200 employees and the gifts are all marked by name. So, not anyone can receive any gift, right? So the gifts are all identified by the employee and each employee should get their own gift, right? Each employee should get their own gift. Now, she is already busy handling these visitors. She is already handling busy handling these visitors. And now you go and approach. Frederick goes and approaches. Hey, receptionist, looks like I have a gift for me. Can you please give me? Now what she does, she goes about searching for the gift in the box. Searches. She searches for Frederick's gift for 10 minutes in the box and then finally locates Frederick's gift. So she takes it and hands it over. When she finished the task and then faced the reception, she will realize that there are a lot of people waiting for her attention. Right? There are a lot of people waiting for her attention. Now, how can she give the Frederick's gift box to Frederick without making everyone wait? Now, what is this process, right? So we said the coordination, usually the work done by the receptionist is primarily coordination, and we related that to our application, right? Our runtime. We said coordination is primarily your IO, right? Any file read write or network read write or memory streams, dealing with memory streams. So these are all your coordination, IO related activity. But how will you describe this process of searching for a gift in the box? How will you describe this process of searching for a gift in the box? This is what you call as a CPU intensive activity, right? This is what you call as a CPU intensive activity. A search is a CPU intensive activity because it keeps the receptionist engaged for a long period of time. Out of the 200 gifts boxes, she has to search the one that belongs to Frederick, right? Now, she has to hand over the gift box to Frederick, but she cannot make any of the visitors to wait. How will she do that? Any idea? So basically, Node is a runtime that is optimized for handling I/O. Node is a runtime that is optimized for handling I/O. Now, not every application is 100% I/O bound. Not every application is 100% CPU bound. The question is, how do you make a runtime that is optimized for IO bound activity to handle a CPU bound activity. I need to make sure that the execution is not disturbed in any way, but still the CPU bound activity has to be completed, right? So how do you do that? How will you do this? Any idea? CPU cores? No. So when you talk about the CPU, basically you are talking about another receptionist, right? Basically you are talking about another receptionist. No, that is not the solution. I want the same core, the same CPU to handle this also. Okay, so here is the thing. The long running task, right? The search is a long running task, isn't it? You need to break the long running task into small chunks and schedule it through the tray. You need to break the long running task into small chunks and schedule it through the tray. So the way it works is like this. Frederick goes and asks the receptionist, hey, I have my gift box here. Can you please give me? And what the receptionist does, she realizes that if she starts searching in one shot, then the visitors will be waiting. So what has to be done? The search process has to happen without making the visitors wait for a long time. So what she does, she picks a number for herself, right? This numbers, right? These tokens that you drop in the tray. So she picks a number for herself and starts searching the big box, right, containing all the gifts. She takes 10 gift boxes and then searches if Frederick's box is there in that particular 10 boxes, 10 collection. Frederick's is not there. So what she does, she doesn't immediately pick up the next 10 to search for Frederick's gift box. Instead what she does is, she drops the token in the queue. And then she drops the token in the queue and then goes about picking up the next available token for processing, right? So she goes through each and every token, and once again she comes across her own token that she dropped there. Now she would pick the next 10, check if Frederick's gift box is there. No, keep them aside and go back to the tray once again. Next 10, next 10, next 10, right? So she repeats this in small chunks scheduled through the tray, and thereby she is able to distribute the work across different visitors. So she is able to handle all the visitors and as well as perform the searching of the gifts. Make sense? Right? So this is the challenge. This is the complexity in building node applications, right? So as long as your application functionality involves plain simple read write, right? Any IO activity, right? No challenges whatsoever. You can very easily build those applications. But the challenge comes in when you have to make the application do a little bit of CPU intensive activity, right? Then what you have to do, it is not pretty straightforward. In other cases, you create a different thread, a separate thread, and then give this task to that particular thread. He will handle it, right? That thread will take care of it. But in this particular scenario, I don't have the luxury of multiple threads. I have to handle everything using one thread. So what should be done? The long running CPU intensive activity has to be broken into small chunks and then distributed across the queue, right? And then distributed across the queue so that it can be processed. Do you understand, guys? Right? Now just to give you a glimpse of it, okay, just to give you a glimpse of how this can be done. Does the developer have to do it or is it automatic? No, Frederick, you have to do it. Right? That's the challenge. That's the challenge. So if, let's say for example, you are building a search application, an application that does a long running CPU intensive activity, right? So it is your logic, right? So you decide how you want to search. Say for example, a very simple, let's assume that you write a what is it? A web scraping tool, right? I think this will be a good case study for us to try. Well, let me see if we can accommodate this during the training. So what you have to do is you have to call different websites, collect the HTML, parse the HTML, and then extract the information that you want, and then dump it in the database. Somewhere you want to dump, right? So basically, you scrap the HTML from different websites, extract the information. Okay. Now you have to do the work. Let's assume that there are no other libraries available, right? So you have to do the work. So you need to make a network call to the server, get the HTML. But once the HTML comes, it is your responsibility, your logic to scan through the HTML, extract the information that you are looking for, collect them, consolidate them, and then write them, right? This is a long running process. Now, when this process takes place, assuming that someone wants to fool you, so what they have done, they have tricked their server saying that, hey, I think this guy is stealing our information. So if a request comes from this particular IP address, send him a huge 10 MB file, huge file, send him a huge file, right? Now when that happens, right, your application will be completely shut down. Why? Because it will not be able to do anything else other than handling this particular request, right? Now this is where this particular technique comes into picture. So the moment you start doing any complex CPU intensive activity in your application, you have to break them into small chunks and then schedule it through the queue. And by doing that, you make the thread attend to all other activities and as well as views. Right? So how you do it? Well, I'll take you that a bit later. But is this clear? Good. Let us see an example of this. Right? Let us see an example of this complexity. And you know what is the interesting thing? The browser behaves exactly like this. The browser behaves exactly like this, except that whom it interacts, right, is slightly different. In the case of Node, the Node process interacts with the file system, with the I/O, right, network, file system, memory, etc., etc., etc. Whereas in the case of the browser, it interacts with the end user, right? It interacts with the end user. So if I have to show you that, right? So let me delete this. Okay. So if you take a browser like this, so if, let's take the Node runtime. So if you take the Node runtime like this, right? So this is your Node runtime. So if you take the Node runtime, it primarily coordinates with file I/O, right? So file I/O, file system, and then it coordinates with network layer. It has to talk to memory, right? So these are all the things that it talks to, right? These are all the things that it interacts with. If you take the browser, the browser almost does the same thing, except that it interacts with the user. The user actions, right, are the factors that it has to react to, right? So now, except these, right, whom they interact with, the execution model of the Node runtime on the server side and the browser on the client side, both are just the same, right? Both are just the same. Now, what I will do, I will explain you the logic of breaking the work into small chunks and schedule it through the queue, right? Using the browser, because it is visually more appealing, so you can very easily understand what is happening, right? So let me create a simple HTML page just to demonstrate this. Right? Browser scheduler.html. So HTML5. Okay. Now, what all I need is a simple text box and a button that says button will work value equal to 2 plus a div where I can display the messages. So div messages. Let us write the expressions. Function, right? That's the input. Comma, right? So now let us define it here. Sorry, yeah. So we will come out. This is this, and let us write this. So window dot add event listener com content builder comma event and function event. So what do I want to do here? Very simple thing. Look at the button. So where button to work is equal to document dot say do work add event listener let us write the function. Function on button to work and we'll say to work and then say display message work and function will work. Don't do anything at this point of time, and then we will also write function display message and say dot you are not supposed to create your HTML like this, but we are not doing web development frames, so that's okay, right? We can compromise on this. Now let me load this on the browser, and then let us see if this works. It works perfectly fine, right? Except that I have not written any code in the do work function. So let us make it a little complex. Let us make it do some complex CPU intensive activity, right? So what I do is where I equal to 0, I less than 10,000, I plus plus, where j equal to 0, j less than 10,000, j plus plus, k equal to 0, k less than 100, k plus plus, right? Do something, right? Now let's go back here, reload this. When I click, right, as you rightly assume, there is going to be a long delay, and then it is going to display work completed, right? So there is a long delay. I have clicked it, so there is a long delay, and then after that it is going to come back and say that work completed, right? Very good. But because the main thread is executing this loop, right? Because the main thread, the UI thread is executing this loop, you will realize that when I click the button, the browser is not responsive at all. See, I click the button, the browser is not responsive. I am trying to set the focus on the text box. Nothing happens, right? But after some time, you will find that at the moment it prints work completed, the focus will be there on the text box, right? The focus is there on the text box. So you execute it using one single thread. Okay, very good. But the most important thing is this. Look at this. I say display message work started. Display message work started. Okay. Now, what do you think will happen when I click the button? When I click the button, what do you expect to see? What will be the behavior of the browser? Work started, and then a long delay, and then work completed. Yes or no? Right? Work started, and then a long delay, and then work completed. Guys, are you following? Hello?
Yes.
Okay. Right? So, unfortunately, that's what you will see. Watch this. That's not what you will see. Let me reload this. Click the button. You don't see work started. I am trying to set the focus on the text box. Nothing happens. And then, after some time, you will find work started and as well as work completed in one shot. What is happening? Right, so let me demonstrate it once again. I click the button, The button is in pressed state. Nothing shows up here. You try to set the focus on the text box, nothing happens. But after some time, you will find it prints work started and work completed in one shot. You want to try this yourself? Let me check in the code so you can take it from the GitHub. Give me a second. Let me just check in the code. This is the repository from where you can take the code. So bookmark this. So every day we will be checking in the code here, right? So if you want to give it a shot, do it and let me know. So I'll give you 10 minutes time. So take the page, post it in a web server if you want, or you can directly load it in the browser, and then run it and see if you understand why it behaves the way we saw. I'll give you 10 minutes time. Yeah, Frederick, I just went through this, but it is not that complex. I mean, conceptually, what you mentioned is right, but the question here is, why is the work started not getting displayed in the first place? Why is the work started not getting displayed in the first place? Very simple. When you execute this line of code, right? So when you say document.getElement by ID of div messages.html, you are not actually writing directly on the screen. You are updating the DOM tree, right? You are updating the DOM tree, and the DOM tree update is a task in its own. So when the browser thread picked up this function for executing, right, you called this function. So this function started executing, and then in this you updated the DOM tree, and obviously unless the original function gets completed, the browser GUI events are executed after the JavaScript. No, DOM repaint executes after JavaScript. Right? So when you say after JavaScript, it is not even after JavaScript. It is basically you have a function which when picked up for execution, right? The functions are atomic unit of executions in JavaScript. So when the thread picks up a function for execution, it cannot do anything else until the function completes. Not only that function, but the function and its complete call stack, right? So when you click the button, this function was picked up for execution, and so as a result, this function was executed, this function was executed, this function was executed. But these functions resulted in the DOM update, and DOM repaint cannot be done on the screen until this function is over. So that is why they were all cached, they were all waiting in the queue to be executed at a later point of time. Is that clear? So where does it maintain? Okay, so this is fine, but my question is, how does the browser remember to repaint the screen after this function is over? How does the browser remember to repaint the screen after the function is over? Right? That is where the event queues comes into picture. The way Node runtime maintains an event loop, the browser maintains an event queue. The browser maintains an event queue, right? So what happens is when you execute it, right? Sorry. Right? So when you executed the display message, when you updated the DOM tree, what actually happened was an entry was made in the queue saying that a DOM update is required. Right? An entry is made in the queue saying that a DOM update is required. And then it goes about doing the executing the function, and once again you say display message, and once again an entry is made in the queue saying that the DOM update is required, and this queue is the scheduler for the thread. This queue is the scheduler for the thread. So once the do work function is completed, right? Once the do work function is completed, once the on button do work function is completed, it looks at what is the next step to be executed. It looks at the queue, it realizes that a DOM repaint is to be executed, so it goes about painting the DOM. Right? So the way Node uses an event loop inside, the browser uses an event queue. More or less the same thing. But in the case of Node, it is primarily to register the IO callbacks, whereas in the case of the browser, it is primarily to register the user actions. Right? Now, so why am I saying user actions here? Watch this. So this is what I wanted to show you. Now, let me click the button. Now, the browser is busy doing its task. I try to set the focus, nothing happens. I try to type something, nothing happens. But then, once the do work function completes, or once the on button do work completes, right, you will see that all my keystrokes are populated right there on the text box. So how is that happening? While the thread was busy executing this particular function, right? While the thread was busy executing this particular function, there were other listeners listening for the keystrokes, listening for the mouse actions, and they all listened for those actions, and as and when something happened, they dropped the entries in the queue, which the thread picked up for execution once the job is done, right? So once this function is done. Does it make sense? Am I clear? I am hoping that I am not confusing your understanding. I am not disturbing your understanding. Guys, I cannot see your faces to know whether you are following it or not. So please don't mind dropping a simple message in the chat window so that I can confidently proceed. Exactly, right, right. So what do you do with set timeout? What do you do with set timeout, right? So basically, when you do a set timeout, you are actually scheduling the function to be executed through the queue. You are actually scheduling the function to be executed through the queue. So the way it happens is, you have to take this and create a separate function. So function trigger work, and here you say do this. And then if you call trigger work directly here, right, you know what will happen? It will be executed in the same call stack. It will be executed in the same call stack, so you won't see any difference. But what you want to do, you want this function to be executed after the DOM paint is completed, right? After this particular task is completed. So basically, you want to schedule the execution of this function through the queue. So you want to make an entry of this function in the queue after whatever is already there. So the way you do it is just pass set timeout of this, right? So when you say set timeout of this, typically what you are doing is you are making an entry in the queue. You are not immediately executing the function. You are making an entry in the queue so that the browser thread can pick it up and execute after whatever is already there is completed. Now, right? Now you see, now if you look at the sequence, when you click the button, you call display message, DOM update is done, the DOM page is updated, and an entry is made here in the queue. And then you say set timeout of trigger work. So by doing this, you are not immediately executing the function, you are making the entry here saying that after this is executed, right? So after this part is executed, execute the trigger work, right? You make an entry here. And how do you do that? You do it with the help of set timeout. So now if you look at this, you will find that it prints work started, and then it goes about doing its regular work. But still the browser is non-responsive. You set the focus on the text box, you type something, nothing happens. So while the long running CPU intensive activity is executing, the browser is non-responsive, right? The browser is non-responsive. Do you understand? Right? So set timeout is a function using which you can schedule the execution of other functions through the queue. Using which you can execute the you can schedule the execution of the function through the queue. Do you understand, guys? Very good. Now here is the most important thing. What am I supposed to do if I want the browser to stay responsive to the user when it is doing this work? What am I supposed to do if I want the browser to stay responsive when it completes this work? You remember I told you, when you have a long running task to be executed, you need to distribute the task, break it into small chunks and distribute it through the queue, right? How do you do that? Let me show you. So here, this, if it is executed in one shot, the browser will not be responsive to the user, right? So how can I make it? How can I make it in such a way that when this is executed, the browser is also responsive to the user, right? So I am assuming that you will be following the code, whatever I am typing. In case if you are not following, stop me, please stop me, okay? So let me break this into small chunks. So where total iterations is equal to 1000. I am making it into 1000 chunks, and then say current iteration is equal to 0 and function one iteration. So this is one chunk of work, right? This is just one chunk of work, and here I say this is divided by total iterations. Okay, so this is one chunk of work, and here I'll say once the job is done, I will increment the current iteration, and then I will check the current iteration. If current iteration is less than total iterations, I have to call one iteration again, but not in the same call stack, after whatever is already in the queue is completed, right? After whatever is already in the queue is completed. So how do I do that? I simply say set timeout of one iteration. Set timeout of one iteration. Else I will do a console.log. I'll say console.log job done. Is that clear? And then trigger the one iteration once. Trigger the one iteration once. That's all, right? Now this trigger will keep scheduling themselves, right? One task, and then it will schedule its subsequent task, which will schedule its subsequent task, which will schedule its subsequent task. That keeps happening. You can also do it with the help of set interval, right? There are different ways of implementing it. I'm doing it with the help of set timer. Now, because the function itself breaks itself into small chunks and schedule it through the queue, I don't need to do this. I can simply call trigger work, right? This can be called in a synchronous fashion. I can simply call trigger work. Are you with me? Now, when you save this, go back, reload this, keep the console open, and now click the button. When you click the button, right, you will see a wrong status. It prints work started, work completed in the UI because this has only initiated the task. So when this line is executed, it doesn't mean that do work is completed, right? The nature of the do work has changed from synchronous to asynchronous. It happens, it completes sometime in future, right? So when this line of code is executed, it doesn't mean that do work is completed. Earlier it meant that, but not anymore, right? But still, we have written our code in such a way that after this second line is display message. So it displays a wrong status. That is why I made a console.log here. This is what indicating the right status of work completion, right? This is when only this line is executed, it means that the job is done. Okay. Now let me click the button. You will find that it printed work started, work completed, but it hasn't printed job done yet. So the job is being carried out. But now look at this. I set the focus on the text box. I am able to type whatever I want to type. But while I am doing this, right, the browser is responsive to the user, right? I am able to set the focus. While I am doing this, it also prints job done. So internally what happened? You kept breaking the task into small chunks and kept scheduling it through the queue, and thereby you also gave some breathing space for these keystrokes, mouse events, etc., etc., etc. to be handled by the thread. Right? Do you understand, guys? Right? So I am assuming that you will stop me if you don't understand. So I am just going to go on. Okay. Now, what am I supposed to do? If I want this to be executed only after the actual task is completed. Now, who knows when the job is done? When the control comes to the second line, it doesn't mean that the job is done. The job will be completed sometime in future. And who knows about it? Only do work knows about it. So what I have to do, I have to wrap this inside a function and pass it. So I can say on complete, pass and on complete here. And here what I will do, I will check if type of on complete is equal to a function, then execute on complete. Now we will pass this as a callback, right? So that is why you use a callback as a mechanism to sequence async operations, right? You will only trigger the operation. But once you trigger the operation, the control immediately comes back. So when the control comes back, it doesn't mean that the operation is completed. Why? You are not waiting. It is non-blocking, right? So you pass a function, and here you say, hey, the job is done, right? Display message that job is done. Now let's go back, reload this. Now this will do it appropriately. So it prints only work started, and then it has taken a function for execution after the job is done. In the meanwhile, the browser is still responsive to the end user, and after the job is done, it is going to come back and print the work is completed. Make sense? Right? Okay. Now, the browser was not actually reflecting what is happening inside, right? So just to give you a visual feedback of it, let me also do one more thing. I will containing the progress with an ID dot progress. That says min equal to 0, max equal to 100, value equal to 0. Value equal to 0. Now here, every time you do this, every time you execute one iteration, I will also take an on progress callback here, and here I'll say where person completed, right? If type of on progress is equal to a function, then call on progress with percent completed. So what is percent completed? We need to calculate it, right? We need to calculate it. So I'll say percent completed is equal to current iteration divided by total iterations multiplied by 1, right? Now this is your on progress. You pass a function there. So function on progress, percent completed, and here you say element ID of progress dot value is equal to percent completed. That's it. Now you have two callbacks being invoked for different purposes, but they give a visual feedback to the user saying that the job is how much of the task is completed, right? So the doer keep posting a message, right, by calling the on progress with the percent completed, and the browser keeps displaying it. This continues, right? This is displaying because you call one iteration again and again and again inside using time set timer, right? You call this using set timer. So if you call one iteration in the same call stack, this will never happen, right? If you call one iteration in the same call stack, this will never happen. You will see the progress bar, filled progress bar in one shot after the complete task is completed, and the browser will still be non-responsive to the user. Whereas now, not only that the browser is doing its tasks, is reporting it, but it is also responsive to the user. Is that clear? Right? This is what I meant as breaking the work into small chunks and then scheduling it through the queue. Right? Let me check in the code. Okay, so for some reason this is not checking in. Okay, right. You will almost do the same thing in your node applications as well, but just that you won't use set timeout. You will use another function called set immediate. Right. So if you look at the node.js.org /API, right? So if you look at the node.js.org /API, you find one called globals. So inside the globals, you will find a function called set timeout, clear timeout, set interval, clear interval. You will also find a function by name set immediate. A process called set immediate. Sorry, where's the set immediate? Right. Right. So you have a set immediate function which you can call directly. It is not in the timers. I mean, it's not in the globals, but it is available as timers API. But otherwise, this is what it does. So to schedule an immediate execution of the callback after IO event callbacks and before set timeout and set interval. So you are not supposed to use set timeout or set interval. You have to use a much more optimized API called set immediate. When in the very earlier versions of Node, right, in the olden days, when Node was still in beta before version 0.5 and all, we used to use set timeout, right? But the problem with set timeout is every set timeout call will take 4 milliseconds. Every set timeout call takes minimum of 4 milliseconds. So it is found not to be very efficient. So you don't use set timeout anymore. You use only set immediate. But ultimately the model is the same, right? You solve the problems in the same way like we did. Any questions? Yes, set immediate is notable. Yes, yes, yes. But these days you don't have to do this. Okay, these days you don't. I mean, this is how we used to solve the problem. So whenever we had to do any large scale, I mean, very complex CPU intensive activity to be executed by the browser, this is how we used to do it, right? But these days you don't have to follow this. Why? Because HTML5 has introduced web workers. So in the browser, you can create multiple threads. See, this is the irony. The browsers have become multi-threaded. Your server infrastructure has become single-threaded. Right? So earlier it used to be your clients will be single-threaded, your server infrastructure will be multi-threaded. Now it is the other way around. Your browsers are becoming more and more multi-threaded, whereas your server infrastructure is becoming single-threaded. Web workers. So Google for it. And if you let me know if you are interested, I will share you the same problem solved using web workers. Do you use a timeout breaks the call stack? Yes, yes, of course. Of course, yes. Yeah. So don't think of it as breaking the call stack. Think of it as creating a new call stack. So now, are you wondering how the variable state is maintained? Right? Closures. So the closures are what is making them possible. So when you schedule the execution of this function at a later point of time, so a closure is created around those variables as well. So automatically that state is available for this function as well. Good, right? So I'm assuming that you're all clear as to what we are doing here, right? It's ditto the same thing, but you will be doing it on the server side with infrastructure, with file, network, etc., etc., etc. Okay, good. Now let us dive into Node. Let us dive into Node. Node is the ecosystem is made of two main things. One is Node, Node.exe. This is the actual runtime, a very, very simple, lightweight runtime. Okay, and before that, right? So Node is all about executing your, building IO-centric applications, right? As long as your application involves IO interactions, right? Node is a fantastic infrastructure for building those applications. That is why when you look at the Node APIs, right? Node.js.org/API. When you look at the Node API, you will realize that all you have, right? Look at the APIs. The APIs are very, very simple. Just one page list of APIs. But you will realize that they all deal with IO, right? You have OS, you have path, you have query strings, you have net, you have HTTP, you have TCP, right? You have buffers, right? All you will see is IO centric. You will have process, but you won't find threads, right? You won't find threads. You don't have threads. So if you want to scale, you don't do it with the help of threads. You do it with the help of processes. Okay. So this is the only set of APIs. That's all. These are all the only set of APIs that are available in Node. And using this, people are building amazing complex applications. How? This is the raw API set, right? The raw API set offered by the runtime. But you have the power of Node.js. The power of Node.js is in the number of modules, libraries, packages available for you to build applications, right? And that you can get it in npmjs.com, right? And that you can get it in npmjs.com. So if you go here, this is, so yeah, what is NPM? Let us look at that. So NPM is a package manager for Node. It was meant to be Node package manager, but now they don't call it as Node package manager. They simply say NPM, right? So even though the reason for it to be named after NPM is that it is a Node package manager. Okay. Now, what do you do with NPM? Using NPM, you create packages. Using for any package related activity, right? You use NPM, and all your applications are considered to be packages. All your applications are considered to be packages, and the packages, right? Node packages are available in millions, and you see this, right? So how many? Hundreds of thousands. So how many number of packages are there? 140,000 packages are available, and they are, how many are downloaded last day, last week, last month. Now, the packages are the most important reason why Node became really popular. Why? Because for anything and everything, I have a package. Anything you want, right? So for anything and everything, I have a package, right? There will hardly be a reason why you will have to build a general purpose package. You will find the packages available for anything and everything in Node. Okay, so this is one of the other reasons why Node became extremely popular. For example, you want to talk to the database. So which database? MySQL. Just search for MySQL. You will find so many drivers available for MySQL. No, I don't want to talk to MySQL. I want to talk to SQL Server. Now search for SQL Server. You will find a driver available for SQL Server. You name it, right? You name it. You want a web server, so simply say HTTP server. Now you will have hundreds and hundreds of server modules available for web server. Of course, their functionality will be different, right? So you see HTTP server, you have tiny HTTP server. There are several HTTP servers, and they differ in capabilities. But ultimately, you have so many choices, and these are all developed by developers like you and me, right? So we can create our own module and we can publish it. Nothing stops us from doing it. Okay. So we will see how you can publish a module later. For now, let us see how you can build a simple Node application, right? Very, very basic Node application. The goal here is not to build a complex application, but to understand how a Node application is structured, right? How a Node application is structured. So what I'm going to do, I'm going to build a simple command line calculator application. Right, a very simple command line calculator application. So let us do this. So folder, I name it as calculator app. Right, I'll name it as calculator app. Now, every package, right, as I said earlier, your applications are considered to be packages. So every package is expected to have a manifest file. So the manifest file will contain all the information about the package. What is the name? What is the version? Who created it? What is the license? What are all the runtime dependencies? What are all the client-side dependencies? What are all the scripts using which you can execute that particular package, etc., etc., etc. Right? So all the information will be available in that particular manifest file, and the manifest file is called as package.json. Right? The package.json is the manifest file for your packages. And how do you create it? How do you create this? Right? So you don't have to manually create it. You can use a wizard that automatically creates it for you. So let me go to the folder. Okay. So I'm here, and the way you create a manifest file for the first time for your application is npm init. So npm init will ask you a few questions, and then by answering those questions, it will automatically create the manifest file, right? So I'll leave the name to be as it is. I'll give the version number as 0.1.0. Description, right? Simple application to demonstrate Node application creation, right? And then entry point. So what will be the entry point for your application? So let me say app.js is the entry point for my application. Are you going to give any test command? No, nothing. Git repository, not decided yet. I don't worry about the keywords, and Magesh K is the author. License, that is fine. Is it okay? Yes, right? So now if you say type package.json, you'll find that it has created a very, very simple package.json file containing everything. Is it clear? So calculator app, blah, 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 blah. So the command using which you created it is npm init, right? Npm init is the command using which you created it. Now, what we will do, we will create the app.js, right? I'm not too much into the user interaction. I'm not talking about how to accept the data from the user, etc., etc., etc. But instead, what we will do is we will hardcode the values and see how we'll learn how you can structure the application, right? So I'll say app.json. So this is the starting point of our application. Let us create a calculator. So I'll say where calculator equal to an object. right? So where calculator equal to an object, and I'll say add is a function wherein you pass x and y and you return x plus y. Okay, now copy this, paste it, paste it, paste it, and this is subtract, and this will be multiply, and this will be very basic stuff. Okay, this is subtract is minus, and this is multiply, and this is divide. Okay, so we have a basic calculator available. Now, how will I use it? Very simple. So I can say where n1 equal to 100, comma n2 equal to 200, and you can say console.log add equal to, comma calculator dot add of n1 comma n2, right? So copy this, paste it, paste it, paste it. So here I will say this is subtract, and this is multiply, and this is divide, right? And this is divide. So a very basic application. You have an object that exhibits some functionalities, and you are using them. Let us run this code. So node app.js divide. Oh, thank you. Thank you. Right? So node app.js, you don't need to say explicitly .js. So you simply say node app, it will automatically execute. Right? So 100 and what is it? 200, and why is it saying 102? X plus y 4. Okay. So this is all empty. This is all empty. Right? So run this. You have 300 minus 100 to 20,000, and then divide is 0.5. Right? So you have a very basic application built. Now, I want to use the calculator in multiple places. I want to use the calculator in multiple places in the application. So what I want to do, I want to make this available as a separate file. So let me take this. And create a new file, paste it, save it as calculator.js. Right? Save it as calculator.js. Now, how will I use it? So, how do I use it? Let us try this. Okay, so you can also interactively use node. So you say node. Right? Now here you can say console.log hi there. Right? So this will execute hi there. So from that particular folder, you can interactively use node. Okay. Now I want to use this calculator. So how can I use that particular calculator? The way you do it is using a function called require. Okay. So you say require, right? We will say where results is equal to require ./calculator. Okay. Now look at what is result. It says it is an empty object. Why is it saying empty object? Right? So in your JS file, whatever you define will be considered to be private. Everything you define will be considered to be private, right? The scope slightly differs from how you do things in the case of the browser. In the case of the browser, by default, everything is considered to be public, and you have to selectively make them private, right? That is the whole reason why I have wrapped this whole stuff inside this function. Otherwise, all these functions will be exposed to the global scope. Yes or no? Right? And I'm hoping that you understand this, why we did this. Right? The whole reason why you did that is to make these functions private. They should not be exposed to the global window object. So by default, they are public. in the browser, when it comes to JavaScript, by default it is public scope. By default it is public, and you have to make anything private by choice. You have to explicitly make it private, right? Now that creates a lot of problem in the browser. So what they have done, what the author did in the case of Node.js is they followed a different approach. By default everything is private, and you have to, if you want to make anything public, you have to make it explicitly, right? So how do I make it explicit? Whatever you want to expose as public has to be returned, right? How? When the node runtime picks up this particular function, it executes it with a handle called module.expose. And whatever you attach to module.expose will be available to the outside world. So here, whatever I want to be accessible to the outside world, I want the calculator to be accessible to the outside world. I say module.expose equal to calculator, right? So I save this file, go back, let me try to read this once again. I will still get the same result. Why? Because require once loads a file within the same process. It doesn't load the file again and again and again. Whatever you load once, that is what is used again and again and again, right? So what I have to do, come out of it, and then once again go to node. Now run where result is equal to require of ./calculator, right? Now look at what is result. Oops, what happened? It's module.expose. Sorry, it is module.expose equal to calculator. I forgot to add the this one, right? So now here we say the result is equal to require ./calculator.js. Now look at what is result. You will find that it is an object containing add, subtract, multiply, and divide. So the way you use it is in your application. In app.js, you will say comma, or you can actually do it here as well. So you say where calculator is equal to require of ./calculator, comma, n1 equal to 100, n2 equal to 200, etc. Now you say node app, it will work perfectly fine, right? So we extracted that into a separate JS file and we exposed whatever need to be exposed to the outside. Make sense? Good, right? So we will stop at this. Tomorrow we will start writing a simple website. Right? So we will start with file reading operation, file reading, file writing, and then we will look at how does it work in the browser. Which one? This doesn't work in the browser. This is server side. What you do is you have built it on the server side. But here is the thing. If you build your modules like this, as long as they don't have any infrastructural APIs, infrastructural dependency, right? You can use a node module directly on the browser. Right? The node modules are created based on a spec called CommonJS specification. So if you want to use CommonJS modules on the browser, you can do it using a tool called Browserify. Right? Using a tool called Browserify. So using this, you can use modules written in CommonJS both in Node and as well as on the browser. But there is only one condition. What is it? The modules should not have any infrastructural related dependency. For example, it should not talk to the file system. If it attempts to talk to the file system, it will not run on the browser. Right? So you can use these modules on the browser, but you will have to use a library like Browserify, a tool like Browserify that converts CommonJS modules to be accessible on the browser. Good. So we'll wind up with this, and then we'll meet tomorrow. And I have a small obligation here. I received a few travel plans today evening. I didn't anticipate that, but unfortunately it came. So we will end up having spillover classes next week. Is it okay with you guys for a couple of days next week? Monday, Tuesday, Wednesday. We will not have the classes for a couple of days this week. We will carry forward it over the next week. Is it okay? Okay. Right. And just out of curiosity, where are you guys from? Pablo and Frederick. Oh, nice. Okay. Okay. Interesting. Good. Okay. What days we are having classes this week? We will have it on Tuesday, Wednesday, and Thursday is not there. We will have it on Friday. Right. So these are all the 3 days we'll have this week. No Thursday, no Saturday, no Sunday. Okay. And then next week I'll let you know by tomorrow, day after tomorrow. Is it okay? Well, thank you so much for accommodating this request, and I hope the day was useful, and I hope I kept you engaged. You find the discussion useful, right? So was the 2 hours work today? My pleasure, Rupa. So the code is there in the GitHub, so you can access it anytime, and I'll try to upload the video by tomorrow morning, because the video conversion takes some time, takes at least an hour. So I'll convert it tonight and then upload it tomorrow and share you the links tomorrow. I have your email IDs, so I'll mail you the video links tomorrow. Right? So thank you so much, and meet you tomorrow. Yeah, same time. Yes. Thank you.